Welcome to the AgEmerge podcast, brought to you by Ag Solutions Network. Your farming challenges are unique, so your practices should be too. We're here to share emerging ideas, build connections, and provoke conversation.
Get ready to improve your soil, your crops, your livestock, and your family's livelihood. I'm your producer, Kim Chase.
And I'm your host, Monte Bottens. Thanks for joining us.
Thanks for listening. We're excited to welcome Dr. Sivam Krish, CEO of GoMicro, to discuss technology that uses phone-based AI assessment, enabling on-farm grain quality checks and assessments through the supply chain. So let's jump right in as Monty and Dr. Krish explore these great advancements in AI technology.
Welcome, everyone, to this episode of the AgEmerge podcast. Joined today by Dr. Sivam Krish. Welcome. How are you doing today?
Very good. Very good, Monte.
Well, we were comparing notes, and he's in Australia, and we're here in the Midwest of United States. So he is up at 11:30 at night to do this podcast. So we really appreciate the extra effort. And he said, "That's okay. I run a startup, and what is sleep when you're running a startup?"
Absolutely.
So tell us your story, Dr. Krish, kind of how you got to where you are today, and then introduce us a little bit to GoMicro.
Right. So it's a very long story. I started my university in Boston at MIT, and it was a shocking experience for a 14-year-old kid from Sri Lanka. Wow. But I just loved the fact that everybody was into what they were doing, intensely into what they were doing. And that is something I have not experienced anywhere else in the other universities, which I find, throughout the world, they are more like factories. So that was a transformative kind of experience for me. And I think one of the most important lessons that I've learned there was from my engineering professor who told me that an engineer is a man who can do for a buck that any fool can do for two. That kind of stuck with me. And I realized that, you got to think of efficiency all the time. How do you do the things really well, really cheaply and economically, and that leads to success. So that's been a very important lesson for me. But to cut a long story short, I am an aerospace engineer by training. I did my PhD in robotics, ended up in Australia, and had a wonderful 3 years in a school where they want me to run programs for kids. And, kids are bored with this thing called STEM education. It's a disaster. Science is supposed to be interesting and engaging, and we are boring millions and millions of kids with this thing called STEM education. So we were looking at ways of interesting kids, and we realized a few things, that kids love their phones. And the phone is really a lab. It's got all the capacity, which is actually better than a school lab. And when you let kids explore, right, because science should be about exploration, they just learn a lot. So we started looking at various attachments, and the microscope, the clip-on microscope, was the one that really took off, and kids would explore and learn things, and it was absolutely fantastic. But as you know, with school systems, things that are successful from an education point of view are not seen as successful. So we started a company after I finished this program called Phone Labs, when that was about promoting engagement with the natural world, because kids are curious about the natural world. So that was going nowhere. And meanwhile, we got an order for these clip-on devices from the Department of Agriculture. And I thought maybe they'll buy 2 or 3, and they ordered 200. And then we realized that, they were using it to give farmers for free, because farmers were sending images of, insects, pests, and stuff like that by post, and they arrived crumbled. So we realized there's a need for detecting insects. And South Australia has a fruit fly free state, so they monitor the fruit flies. And we thought, if we develop a solution for assessing, detecting fruit flies, there'll be use for it. Well, turned out, as you know, anything that's run by big organizations and departments, they're not necessarily looking for solving the problem. So it didn't really go anywhere. That was a shocking experience. So we thought, Well, made some programs with fall armyworm detection, which we cracked successfully, but we realized there's really no market. The pest and plant disease are a huge disaster. I mean, cost a lot of money, and it was very difficult to enter the market. So we also kind of realized I'm completely outside from agriculture, still finding my way through it, bungling through it, shall I say, to be correct. And we realized where there was a market was in food quality assessment. So then we switched on to food quality assessment. But in that journey, something bizarre happened. We had to photograph the fruit flies, and fruit flies just refused to pose. So we put them on ping pong balls on a device like this, and we started photographing fruit flies because you could shake it up and get it to go this way and that way. And we realized we could do with 50 images, differentiate fruit flies from other flies, what took other people 500,000 images. We just couldn't figure out why. And we realized after a year, it took us a year to understand why this was working, is because we had eliminated the shadows and we had eliminated the direction of light. And that just gave us a 100-fold jump. So as you know, in AI, the big barrier that has plagued the introduction of AI in a lot of areas is a variability in lighting, in camera quality, and so on. So we cracked that problem. So we applied for a patent. And then we realized we could, assess grains and legumes and everything else really well. So that's how the shift to food quality assessment happened. So that's how I got into this.
Well,
I see some accidents.
Yeah. No, I think that is great. A lot of great things come out of the result of an accident. So a couple things I picked up on in your story. It's true. Bureaucracies are the same worldwide. They try something, but they don't really attempt to go through on it. Like you said.
No. Yeah, absolutely. So the STEM education is a good problem, right? I mean, the elephant is not STEM education; it's boredom.
Yeah,
we are boring kids in their millions.
Yeah,
right. And there's really no incentive to solve that because learning is something that should happen. If you solve that problem, it'll happen. Right. So when you give an organization a responsibility to solve this problem, very often the organization have an interest in continuing that problem because they have no incentive to solve it. So you find that with a lot of areas of government or organizational activity.
It is so frustrating, isn't it? But
yes, it is.
But I think I liked your example of bungling through, and I you know what, we are all bungling through whether we know it or not. We don't know we're bungling through until we look back over time and see that. But it's interesting to bump into those. So it's one thing to take the picture. And that's, we've had a lot of vision related tech startups on the podcast. So we've talked about those various things about, angles and, being able to perceive distance and identify things. So that is certainly an interesting platform, which I would assume what you've developed is fairly low cost. It attaches right to modern smartphones. And so you've already got the high-tech sensor. It's just augmenting that sensor. But talk to us a little more on the back end then. How do you take that information then and develop that AI engine, and what all's involved in making a solution or a product out of that?
Good. So I think that's just the start. So we have a good start in terms of reduced number of images and high accuracy, but that's not all. Right. What we have, I happen to develop some expertise in this thing called generative design. So when I was teaching design in Singapore, I found designers were just mindlessly massaging things and creating design. So I created and even patented the first generative AI CAD. I have a LinkedIn following of a group of over 10,000 members. This is what I would be known for when because I pioneered how to generate images without using the human brain, right? And this is the basis of generative design. So this, again, I formed a company, failed. Absolutely nobody was interested in this technology 10 years ago. But out of that, I developed the expertise to generate images, including fake images. So we are able to synthetically create images and use that for training. And that made a huge jump in our ability to train very fast and with very small sample set. So the overall process is extremely simple. People put images into a Google folder. We take it, we build the engine, and we build a platform, so we deploy. So if you give me a new type of wheat or a new type of grain, whatever it is, if you give us the images, within a week, we will build and deploy something that hits about 98% or close to human accuracies. Now, this took years and years and years before, and a lot of companies just died trying to do this, and they have a lot of failures along the way. So it's three layers of technology. So we have a technology stack, we have a way of acquiring images, we have a way of also obtaining images for training and also for deployment using the same device. Then we have synthetic image creation, and then we have a platform, and now we can also do video. So it's a whole series of abilities stitched together, which makes it possible for us to do what we do.
So I apologize if I got this maybe completely wrong, but are you able then to essentially generate what the perfect specimen would be, and then you compare what how close to that perfect or that the specimen is that you're sampling? Is that a way to say that? Or
So what
because you're
now,
grading on a continuum, if
no,
I
no, yeah, exactly. So let me kind of explain to you.
yeah.
So wheat, there are 5 types of defects: say shriveled, black tip, infected, fungus, and so on and so forth.
Mhm.
The reality is that you normally get 5 to 10% defect, right? Which means then you need 10,000, 20,000, 100,000 images with 5% defect. So it's a lot of work. So typically what other companies do is they cut these things and they manually annotate it. It's too costly to do it in the US. So they probably send it to Africa, India, or somewhere in Asia. And then these people who annotate probably have never seen black tip or they don't know what they're doing, right? So they make a lot of mistakes. And then you get bad data and you train with it and you get bad results. So we avoid all that. So we don't have sweatshops. We don't need sweatshops. We generate these images synthetically, and we also use some natural images. So it's a combination of both. Have I explained what we do? A little bit more clearly,
Yeah.
I hope.
No, that's great because and then that's how you're able to do that very short time scale of
That's
a
correct.
week to get to 98% of what would be industry standard today, correct?
Absolutely.
Plus, now back to your the fool does it for $2, an engineer does it for $1. In this case, you're probably the industry, the fools are doing it for $30, and you're probably doing it for 3 cents. I mean, talk
That's
to me
correct.
about the economics of savings using your technology.
Oh, it's unbelievable. So we've basically not funded yet. We've raised something like $250, early stage. The competing companies have raised millions of dollars, and they still don't have a product that's anywhere closest to what we have. So should tell you something about what we do. On top of that, grain is not the only thing we do. We do tuna assessment, tuna grading. We do fresh produce. We're working with a major US supermarket chain now to do strawberries. We've done bananas, we've done tomatoes. So, because we've done this very wide range, we're doing lettuce now, lettuce quality and freshness. So we've got a very wide range of experience, and all these devices are 3D printed, no injection molding. We could never afford injection molding. So we've inspired by this whole ability to knock things out quickly and quickly introduce. This is exactly what Australian farmers do. They build things quickly with what they have and test it out. And so we've managed to learn a lot by doing a lot of things, even though we are not funded. So I think that puts us in a very powerful situation today, in that we can go into a new area and crack it.
That is awesome. So we have some strawberry farmers, lettuce growers, and almond growers You mentioned a few of those things that listen to the podcast here. So talk to us about this a little bit. Currently today, they would look at, size. So, on an almond, for example, kernels per ounce, and shape. They'd also look for blemishes, so any cracks to the
Yes,
skin.
yes,
And what they would do there is basically run it through the machine and see kind of a sorting. They'd have a table process for weight. They'd have maybe a color sorter for damages and those kind of things. And
yeah,
then you kind of know the after the fact, correct? But here you could literally take a picture of a bin, right? That's been shelled, and know what you have ahead of time, correct?
yeah. We've working with the Almond Board of Australia, and we've built something really, really cool. I don't want to disclose too much, but
Darn it.
Australian
You're
farmers
our
will be
competitors.
right. So yeah, you'll be on the news because it's a breakthrough.
Oh, good.
So hoping to look at it in another way,
Or like navel
right?
orangewort
So
detection, for example, navel orangewort damage, and that's a huge issue that can be hard to detect.
absolutely. So look, we're going, kind of going past the point where anything that you can do by eye, we can do. I mean, we can give a money back guarantee. That's dead easy now, right? We are now beginning to do things like things that you can't do by eye on the edge of eye, like tuna grading. You can look at the eye of a fish and tell when it was caught. I mean, to an accuracy of 1.5. We can tell when a lettuce was taken out of a fridge to an accuracy of an hour. We can do ripeness. So we don't know what we can't do. We are in those very weird situations. We are very much part of the AI revolution in that we don't know where the edge is. So it's a very exciting time. It's a thrilling time to participate in the kind of stuff that we are doing. That's one thing. The second thing is, you right now we are using cameras. There are near infrared, there's ultraviolet. That's going to open up a completely new spectrum of possibilities. So we're very excited by that. We're also beginning to explore that. But looks like the possibilities are just amazing, right? And then you can do it on video, which means that you can put this on a harvester. And then you get into an interesting situation where you can map wheat seeds, right? So right now they're mapping protein and moisture, and we can map where the weeds come from. And then, of course, it can be used to do selective spraying. You can decide what kind of herbicide to use. And a lot of applications we're very excited about. So yeah, so very, very exciting possibilities around being able to put this everywhere. That's the whole thing. That's where the power is, not by building one machine that sits in one place in one application. We're in the business of democratizing this, building engines, putting it everywhere.
I could tell by the smile on your face you're like one of those students that was let free to go do what they wanted to with their
Absolutely. So I love Australia. You can ignore people and do what you want to do. People don't, and we're not funded, so we don't have a board telling us do this, do that. So we are free to explore. And I think so many years of exploration is finally bearing fruit. We've now got enough in our plate. We can't do more. So yeah, we've got to that interesting point.
The AgEmerge podcast is brought to you by Ag Solutions Network. The ASN team is hands-on, digging in and invested in regenerative agriculture. Along with the proper plant nutrition and biologicals to boost your soil microbiome, we provide the ideas and implementation guidance to support you on your soil health journey. So stop farming the same way and contact Ag Solutions Network today at asn.farm.
So a lot of the things that you've talked about here are really in the supply chain between where it is, harvested or caught or, manufactured and processed up, from a lot of business to business transactions between commodity traders or brokers and those kind of things. Talk to us a little bit more about what this can mean for the consumer. So when we get into the grocery store, or we get to the point of purchase by a consumer, how can this empower a consumer to purchase maybe based on nutrient density of the product. I don't think they can trace it as far as was this fish caught ethically or not, or was this animal raised pasture or not. I don't think they can probably do that with the AI technology, but they can certainly tell the quality of that and kind of have a because quality is not either good or bad. It like you say, it's a continuum, right? So, but then the price also needs to be a continuum too. So there becomes a price quality ratio. So how can that enable the consumer to make those better choices?
Monte is a very, very interesting question. And I think that's where the value is for us. End of the day, there's traceability. As you know, traceability, in my opinion, is going nowhere, right? There's a lot of expense and there's no additional value out of that expense. That's the problem. Traceability needs a value proposition, and that value proposition is quality. If you marry quality with traceability, you've got it working, right? And that's what we want to achieve. Because consumers want to know whether the fish is caught ethically, but they also want to know whether it's cat food fish. So I think what we are seeing is to catch fish ethically, there's a lot of data and there's a lot of trust involved. Fundamentally, I think for consumers, if you want to address their concerns, we are in the business of managing trust. Okay, that is what it's all about. So traceability goes a certain distance, but it doesn't address the issue of quality, right? That's one part of the story. The other part of the story is that quality itself is a very complex thing, isn't it? I mean, look at current trade now. Every country has its own standards, right? So I think we have to democratize the way we measure and assess quality. So look, if we can build an app for you in a week, we can build an app for a company, for a buyer, that tells other people what they would buy, which means they can send it by the supply chain, and everybody along the line will know exactly what they want.
So you can do predictive sales. So that would really you smooth out that whole supply chain process. So you'd have things priced appropriately on everything. You'd have less waste.
Absolutely. Not only that, right? It could become a sourcing technology, right? So, Australia exports high quality wheat to countries like Japan, and they're very specific about what they want. Now, here's an opportunity for a buyer of something very specific to pass down the requirement all along the chain to the farmer. And the farmer can then sell it straight. Why does he have to go to all these other agents and lose bits of revenue, right? So this will connect the dots. So that's what we want to do. So the big difference in the way we think about quality and the way others are thinking about quality. Others are servicing existing work processes. We are stupid enough to ignore that and suffer through it, because we are inventing the next paradigm of quality, which is definable and transmittable and verifiable at all points. So that's a big difference. It'll take some time to happen, but that's what we're working on. And we have got the technology already for that. But as you know, markets will take time to move.
Yeah, it's what needs to happen. Most startups, you're not, you didn't go to startup school. Where they tell you that you do an incremental change in a large addressable market that's easily adoptable by the existing supply channels. Okay, so nobody told you were supposed to go to the ADM and say I've got something to replace your quality assurance lab fees.
Totally. So it's kind of interesting. We've been told by investors that we've no direction. Guess what? They're right. Why? We're doing fish, seafood, or grain or fresh vegetables. So we have no direction, right? And that is true. And we want to be that way. Because there's one thing, AI is such an amazingly powerful technology. It doesn't care whether you're looking at seafood or grain or anything. It's the same platform technology. So we are building at a high level. The difficulty is in marketing. Every market you go into, you realize, oh my God, we don't know how this works. It takes 7 years to figure that out, right? Every market is so different. So it's an interesting time in AI. As you see, a lot of AI companies are already crashing, and they will continue to crash. I think the companies like us that actually apply AI to real world stuff are the ones that will ultimately create value because we've figured out how. AI can't eat AI. You can have a hype, you can write a hype cycle, but it's got to touch the ground. And we want to be that company that actually touches the ground.
Let me throw something out there for you, just in my opinion. What would you consider being the AI startup for AI startups? In other words, you would be the people that would provide to each one of these startups that want to do that maybe incremental change to essentially you've democratized what you have, and you license out your expertise to 100 companies that are saying, hey, I want to replace vomitoxin sampling, or I want to place tuna freshness sampling, and then they take it and go from there. I think that would be an interesting direction based on what I'm hearing from you.
Absolutely. So we are looking at it this way, Monte. We are looking, as I've kind of explained to you, agriculture, trade is about trust, right? AI, nobody should trust AI, and nobody will. Right? So fundamentally, it's about human trust, right? And the way we look at ourselves is that we are a platform to deliver that trust. So we'll work with the associations and create a standard for them. And that we know nothing about almonds, by the way. We know nothing about tuna. We know nothing about grain. We don't have to, because somebody who knows it has given us the images. We build the app for them. They have tested it. It is their credibility that we deliver. So that way, we're not experts in it. I think we don't have to be. But so if you look at a lot of other AI companies, they're just so excited about AI and AI and AI and AI. We are not. We are looking at, how do you deliver human expertise using AI? Because fundamentally the final arbitration is with human beings, right? So we have a different take on how we see ourselves.
Interesting. So let's back up just a step, Dr. Krish, on, most AI, we hear it a lot, right? And dairy farmers are we talking artificial intelligence, or are we talking artificial insemination? The two of them.
I've been asked that
It's tough.
question.
It's tough in their particular industry. But let's say on AI, we're familiar with it, and we hear all this stuff it can do, and we've seen that it can write, and we kind of know on one hand that it's helping students cheat on their essays and tests and stuff, right? So that's kind of what I think a lot of people know. And then there's the other, it's going to kill us all, right? It's going to replace us. It's waiting to it's the boogeyman. But there's this huge gap between those two. Explain a little more what you see as that kind of that gradual thing. And the good news is, folks, I just heard Elon Musk speak yesterday, and he says him or another person he knows thinks there's only about a 20% risk that AI is going to kill us all. So, that's good. We got 80% chance of still being here. Talk to us a little bit on more broadly how AI is entering and where it's going in our lives, and in your thought.
Well, this is something I worry deeply about, and something that is of concern to me. End of the day, it's a tool, right? Every time there's a tool, there's a lot of worry, and there should be worries, right? The same fears were there about the internet, and so on and so forth. And finally, the nuclear bomb, right? I mean, the question is, whose hands is it on? That's the one question. And is it democratizable, right? If it is democratizable, you have power distributed. which is, I think, creates a safer world. I think power concentrated in one country or one organization is a formula for disaster, right? So if you look at the amount of AI learning that is going on, the amount of AI expertise that is being built globally at a phenomenal speed, it's really very heartening to know that it's a global phenomenon, right? So I think the only way to make the world a safer place is to distribute that expertise, right? And make it easy for people to build their own thing, right? So that's one side of the story. The other side of the story is that, you need what, $100 million to train an AI engine like a large language model, right? And then that goes into concentration of capital and power and people who want to do other things with it. So that's a different kettle of fish, right? So we are not in that game. We are in the other extreme. I teach 10-year-old kids how to build AI apps. We've been sponsored by the South Australian Libraries to teach little kids, right? So we are on the other extreme. So I think it's going to be a very interesting future, but it is extremely dangerous. And I think the danger is to do with the fact that it is becoming so powerful so quickly, and it can be used in the hands of the people who have power to further their goals, right? And look at us as a species, right? Now, end of the day, we might become like rats compared to superintelligence, right? And there are countries, I don't want to mention names of countries, but there are countries where the power of capital is so intense, they have no heart for the population. You can have huge amounts of poverty and extraordinary wealth and skills concentrated in the hands of few. And you have countries like Australia, for whatever said and done, it's a lot more even country, and there is, I believe, genuine concern it's a flatter society here, right? So in countries where there is a few people feel they can essentially trash human beings, and that's okay, that is a very dangerous situation, because AI actually now gives such people the power to make those situations even worse, right? So we are living in both an exciting and dangerous moment, which is completely out of control. I mean, this is not controllable. So that's the other side to it. That's one side of the story. But neither is the human population controllable. We are ruining the planet, right? The planet is not sustainable, right? So how are we going to crack that problem? So the way I look at it, hey, this is amazing stuff. It's powerful, dangerous, and everything. Let's do good things with it.
Right.
So that's how I look at it.
Well, I agree with you. It's got the potential to be good or bad, right? And it's just like money isn't evil. It's how you use it can be evil, or how you use it can be good. It's a similar thing. But yeah, trying to regulate it, the toothpaste is pretty far out of the tube, and regulations are pretty slow to catch up. I don't think that's going to happen. So I agree with your get the ability for multiple entities and people to be able to generate and essentially create AI competition with itself, and
absolutely
is a way to do that. So thanks for sharing your thoughts on that. I think there's a fair amount of concern from people that aren't in it every day, like yourself. Just what is going to come of artificial intelligence. So yeah, very, very good.
I think we have to learn to live with super intelligence, but don't forget that was created out of using human intelligence, right? I mean, if you look at the amount of work that these engines are learning on, it's based on. So in a way, it is a fruit of human intelligence. But so that's the beauty of it and the power of it, and that's also the danger of it.
So tell us a little more. You've been bragging up Australia an awful lot. So tell us a little more about the Australian startup community and what it's like.
Right.
kind of
Right.
compare
What
that
is
to other areas of the world that you're familiar with.
right? Look, I think I think it's, I mean, in retrospect, as I said, I went to this university, and my brother says I never went to a proper university because it was a very weird place. And I think he's correct. And in the US, you grew up believing that technology is about risk, it's about trying to do stuff that you can't do. And there are crazy people out there to fund it, and there are a few people who are crazy enough to get it right. So that's the kind of mentality in which I landed here. And it was a complete disaster. Australia is deeply conservative. There's no real VC funding for high risk projects. And it's really, we've struggled very, very much to raise funds. That's one side of Australia. The other side of Australia, an Australian startup, they're quite tough. They're like cockroaches. They survive. They're survivors, right? Australian farmers are just the same. They're resourceful. They, all the problems, there's no water in South Australia. It's a desert. We go out there to see the farms. It's amazing what the farmers have done in this country, right? So you have the mix of these two worlds. So things tend to be conservative, but, like we didn't have funds, so we didn't burn a lot of money, right? So it's a low risk profile thing. But I think we are now in an era of globalization, which means you can live wherever you want and address global markets. So life is good in Australia. Wine is very cheap in Adelaide. You have a good life here. Tackle the global market. And of course, you miss out the circus that the rest of the world is kind of, it's isolated. So you don't engage in all the other stuff that's happening. So on the other hand, I think there's a huge amount of, I'm a big fan of the capabilities of farmers in this country. One of the things that shocked me when I brought my kids to school, year one class, they took out this tray and it had all these tools. And this is in year one, they have hammers, pliers, screwdrivers, and all that. And I thought, oh my God, how amazing is this? In Asia, you go to school to avoid touching those tools, right? So you never have to do anything physical. So there's a good culture here of making things. And also there's mateship. I think that there's a lot of, the amount of support you get from fellow entrepreneurs is just quite amazing. The amount of information sharing among farmers is very interesting and very positive. So there's a good, so it's kind of interesting. You don't have capital, you don't have the kind of ambition, and you can't do the things that you can do in the US, but it's got a different mix of capabilities. So that's what's really interesting about Australia, and that's its strength as well.
And it's interesting how you say that because a friend of mine, I have some farmer friends down there, and they always like to brag to say, hey, there's no such thing as a bad farmer in Australia because we have no government subsidy programs. If you don't, and there's no safety net. If you don't make it, you're out of business. So he says we got rid of a lot of the bad farmers a long time ago. So, there is some truth to that. So it's similar like what you're saying that you're dealing with in the startup community. Very, very robust and cockroaches is not the most not the most best term, but I understand what you're saying there. It just can't.
It's a
your
good
survival is
that you survive. I think you survive. Cockroaches, it might not be pretty, but it survived for centuries. It's tough. It's resilient.
Yeah,
I think there's some value to that.
Yeah,
you don't have to look pretty. You survive.
Well, okay, you have your crystal ball there on your desk next to you. Dust it off here a little bit. And tell me what the future holds for you and GoMicro. What do you see in the next you pick the time horizon and tell me what's the future.
Right. I think there are a few things that we have already demonstrated in terms of how using the phone to do some amazing assessment, getting up to human level and beyond. What we would like to do is to put this power of AI assessment in the hands of everybody. We are obviously focusing on agriculture, and we believe we can solve a lot of problems in agriculture, like food waste, right? Food waste is because a lot of times you don't know what the state of the food is, right? I mean, when we are talking, AI can predict the next word, but you have an apple, you don't know when it's going to spoil. How silly is that, right? So there's really not much good technology for food assessment, quality assessment, shelf life. So we are working on these problems. So this is one thing. The second thing that I think that's really interesting and meaningful to me is the fact that, you know, farmers, there are many types of farmers in Asia, Africa, Latin America. Farmers are poor. And I think AI can help them and can help them get better pricing for their product and can essentially connect them to advanced markets through traceability and quality assurance and stuff like that. So there are a lot of positive uses for AI. So we like to engage in the positive side of AI and make it available for thousands of users. And I get a big kick out of that. That's why I do what I do.
Now, as far as the total impact and what that will mean, when you look at the ability to AI quantify that quality continuum and connect those markets, have you put some math to it, whether formal or napkin math, what that means in
Okay.
value savings
So
and waste savings and value, and plus ultimately doesn't and share how this can then translate back to the farmer and won't just all get caught up in the middlemen.
okay. So farmer is spending what, a year or half a year growing stuff and he's selling stuff. And he's got really no way of, he's not in control of what he's growing, right? He's taking it, driving it, and somebody determines the quality. Sometimes they do it right, sometimes they do it wrong, sometimes they're opportunistic, right? So if you put this on a harvester, you have phenomenal record of quality, right? And then the same technology can be used on the receiving side. You have no chance for any conflict, right? You can then export it and some buyer on the other side can look at it. So you take out the risk. So between the farmer and the buyer is all these value is eroded by people who are essentially de-risking trade, right? So in industrial countries like US, I think US farmers have 50% of them is, can store their grain, right? 50% or something, 40 to 50%. Same thing in Australia, right? So they also store grain, they want to. So industrial farming is pushing farmers to essentially act more like companies. They have transportation, they can store, they can decide to sell their online platforms, right? And they want to get the best price, right? So in that context, you can removing the uncertainty, they can benefit from it if they control the sector. So that's the benefit from the farmers side. There are other countries where farmers get fleeced because the buyers have all the power, right? And they have absolutely no power. So here it helps them because some company is going to figure out how to build that, use that, and also build social trust because people are willing to pay a little bit more for ethically sourced produce, right? Tea, cocoa, coffee, all these are smallholder farmers, right? So value propositions for farmers in different contexts. The other thing is, end of the day, it's, there are input costs, fertilizer, herbicide, all these have to be now used very carefully and judiciously. And knowing where things come from is going to be very useful and is going to reduce the input cost. So that's a very significant benefit. Thirdly, machine settings. As they're harvesting, you have to set machine parameters and you don't really know how to set it properly. So looking at what's being harvested, what's being rejected is something that can optimize what they do. So I think there are lots and lots of benefits. And farmers in Australia sometimes, drive for, hundreds of kilometers and the truck gets turned bad saying that, it's animal feed. So they have a choice of cleaning it. And that's some cost as well. So cleaning decisions can be made, right? So what we have learned is that whenever you can make decisions at source, the farmer has a lot more options. But if it's driven all the way and you've spent that money booking the truck, paying for fuel, then you're a price taker, right? So basically, this will help farmers, instead of being price takers, they can decide whom to sell, what to sell, how to mix grains to get to the certain standard. So, what you call blending. So there's a lot to gain for on the farmer side with the AI assessment technologies.
That's just great to think about because there's so many times when, maybe I've taken a load and I could have gotten a higher premium for it, or maybe it didn't receive the premium. And yeah, like you said, you've got all the trucking and hauling costs sunk where you could have cleaned it or done something different to it. Great points. So let me ask you another place to apply AI sensing, vision sensing. Have you thought about how this could be used on soil itself, or on maybe live animals, or on live plants, and pre the product that we're selling?
Very, very interesting question. So I can come to this from the point of view of generative design,
Okay.
right? Because I think what AI is figuring out and doing. So so people forget this. Engineers don't really understand nature, right? If you look at the publications on design theory, volumes and volumes of absolutely useless stuff, right? Nature has been designing for billions of years, right? We have all these professors wasting everybody's time issuing degrees. I think they are utter waste of time, personally. Nature has been designing for billions of years. Nature knows how to design very, very, very well. And neural networks came about because it's imitating the human neurons, right? I mean, that's the basis of a lot of stuff that we do. So I think there is going to be like people had plants, they didn't know how it was designed, they didn't know how it came about. Darwin figured a few things about it. Mendel figured about genes. So there's a genetic structure right behind things, and these are now biological genes, right? And what generative AI is going to create is geometric genes, right? That will help you to take a picture and create a structure. And from that, it connects to what the plant really is. So I believe that generative AI is going to have immense abilities to look at something and tell you what the soil is, because particular plants react to soil and nutrients in a particular way, right? So I think this whole thing really relies on something that I was very passionate about, which is generative design, which is now used in animation. All these trees that you see in movies are generated. They're not, sculpted and done by hand. So I think that is the fusion we'll see. So which essentially means that all the old world methods of assessment and analysis, where you put probes in and so on and so forth, are useful, but they'll be only used for calibration. The real useful data will just come from images. So that'll, I think, be a big game changer. And you can begin to see pieces of that already coming together.
Okay, farmers, imagine sampling your soil. Instead of 1 pound for every 2.5 acres, that's a standard here, or per hectare, one pound of soil for that, you essentially can take an image everywhere and get, a full assessment. So that's pretty exciting. And just the changes that are going to come in the next few years are mind-boggling. So,
Absolutely.
and I'm
Absolutely.
glad you're one of the people causing all the trouble. Well, in our time here together today, Dr. Krish, what else should we have visited about, or other things you'd like to share about yourself or GoMicro and your team?
I think, we're into a very exciting future in agriculture. And I think what I would encourage people to think about is that, you know, there are genetic structures. So for example, you're looking at wheat, and there's near infrared spectroscopy to assess protein content, right? But there's also a company in France that's looking at the wheat with a camera, the phone, and telling you the protein content. Why is that possible? It's possible because all biological products are connected, right? By looking at one thing, you can guess the other thing. So I think I would, so there are immense possibilities, and you don't have to measure everything the old world way. If you have data and if you have reliable AI, a lot can be inferred. And I think I would encourage farmers to think that way and see what you can actually infer from AI and how we can connect the dots, because I don't think you can solve problems by solving it piecemeal. I think there's a lot of value in assessing and understanding and connecting everything. And I think AI is going to make that possible. And I think we're heading for a very exciting future in that direction.
And I think that's a great point because everything grows in a system, and you change one thing, there's rippling effects across that entire system. And today we're just doing these one-off and assuming. And I think that we'll be able to get a much better holistic picture of what's going on without our personal bias, right? There's so much personal bias because dad did it, granddad did it, neighbors are doing it, industry is doing it. Um, AI gives us hope of cutting through that bias, right? That's something we really didn't talk about. It sees the data for what it is, unless there can be bias built into the model, I suppose. Talk about getting away from that bias, human paradigm.
Right. So I think, so there are two sides to this, and fears as well, right? So the fear with the big data things like LLMs is that, few organizations control everything and we become like robots, right? So that's the fear, right? So that's the fear in engaging with big data and being told what to do. On the other hand, there is also this fear of this is how we used to do things, and if you change it, it'll not work well. There's a problem, right? So I think what AI is going to be able to do. I mean, so we are looking at a generation of farmers who are acquiring knowledge, through universities or from their father or grandfather or their neighbors or what. We have a certain way of acquiring knowledge, right? Now, I also notice in Australia, farmers are experimenting all the time. Every season is an experiment, right? But the knowledge of that experiment is not passed on to the neighbors, or neither is it captured, right? And I'm hoping that it would be captured and shared, right? And done in a social way, not giving it to some university to publish some paper that nobody reads, right? Not that kind of stuff. I ran away from that, right? So I think there are some really interesting possibilities of knowledge sharing and having the power to do your own research. Now, the interesting thing is this: climate is changing, varieties of plants are constantly being engineered. There's also no wisdom, right? I mean, things are going to change all the time. There are new machines, new possibilities, new markets, right? So you got to have an experimental ability and able to do those experiments yourself and make sense out of the data. So I also think this calls for a new type of education, which is hands-on, experimental, and has an element of knowledge sharing. And this is why I think, one of the things that I love to work on as a retirement project is this whole notion of, can we build genetic models for plants, right? Can we make it like a game, right? You put so much of fertilizer, what will it actually look like? And then can you go take a picture and see whether it corresponds to that model, So this whole notion of modeling, and building knowledge out of that and correlating it to so that's the whole interesting thing about digital twins, the ability to correlate with what is there without too much of hassle, just from photographs. Then the farmers will be able to build a mental model of what's really going on and what affects what, right? So I think the way that the university ways of doing stuff is really quite out of date. I think animation and games technology and good basic understanding of AI will essentially make farmers more knowledgeable and able, because farmers are decision makers. They want to know, if I do this, what will happen, or should I do this or not. So I think we need to look at different ways of maybe I'll start a school for agriculture.
I was thinking there as you're talking that we need to stay in touch. There's some great things there because I think about just how many accidents or oopses happen on a farm, and yet they're learning experiences, right? And then do those learning experiences get transferred into new practices? And then there's the intended trials that then do they get assessed and translated into new practices? And then there's things that happen that we don't even recognize happen. So there's really three categories. We intended it, we screwed up, and we didn't even know we screwed up. And yet each one of those we can learn from, and yet we're missing that today. And even if we do get good information today, the probability, because of bias and peer pressure, of it changing to a standard practice isn't happening. So if there's a way we can, help change that paradigm of thinking in order to adopt better regenerative agriculture practices. I like how generative AI and regenerative, hey, it sounds like there's a marriage there. We can make that happen. So
One thing I forgot to mention. I mean, I think the problem is that the world of knowledge is being disrupted, and I think there's no tree to hang it on. That's the whole problem. You have the academics who are in the publishing business. They're only publishing, right? They publish or perish. They publish and publish and publish. Then you have the chemical companies who are selling and selling and selling, right? And then there are gene companies who are like editing, editing, editing. There's nowhere to hang this on. We need to figure out a way of something that we can hang on, some kind of a mental model of how all these things fit. So it has got to be a beautiful educational scheme that has elements of gaming and visualization, and people who can play around. I mean, I have ideas. So look at what's happening with automation, right? I mean, do you actually have to have monocrops now? If robots are plucking, you can have an apple tree and a pear tree next to each other. There shouldn't be a problem. And they don't need to be in a straight line, because you can have vehicles that go this way and that way. You can do so much with automation and AI that can actually help, right? The other thing about regenerative farming is the complexity is very, very high, right? AI is good at complexity. The problem with industrial farming is it's formulaic, it is dumb, it is overdose everything, and it just ruins everything in the long term, right? So AI, and I think regenerative farming, and that's what you kind of alluded to, generative design, is what allows complexity. And the reason why is AI able to do all these amazing things? Because suddenly we got to a point where we have so much of computational power, we can deal with complexity. That's the only thing that happened. Right?
That's right.
There's nothing else.
And I think that's one of the barriers to farmers adopting regenerative farming is it's harder. It's more complex. It's more management. It's maybe more labor. But if we can get the
and more uncertainty
in there for the labor, we can get AI in there for the management ease and decision making. Now regenerative will be the conventional farming practice.
Right. And also uncertainty, right? Because the conditions. So the way you do industrial farming is you control all the conditions to very narrow, manageable, machinable kind of stuff.
We need to flip that upside down and let chaos happen. And then out of the chaos, learn the best practices and derive the value from that.
Exactly. So a very interesting project by CJIR. We were kind of involved and not involved in it. So, all these plant breeding trials, right? They do the trials in a lab, and they do this for Africa, and they put it in the field, and the results are very different, right? Mm-hmm. So then the question is, can you do the field trials on the field, right? In real farms, right? Which is absolutely possible now. So this is the same model that you're talking about of, experimenting constantly as you do it, learning from it, and then sharing that information, right? And to do that, you have to have a model and a language that farmers understand, that is shareable, that is constructible, that ties to human imagination and understanding. And I think the way we have this whole science education doesn't do it well,
Yeah.
So I think that's where the educational breakthrough is needed, I think, to just create mental models that can then connect to photographs and create you the real stuff, and then give you the numbers that the old world science would have done with its archaic equipment more accurately.
I agree. I so appreciate you sharing. I can tell you're a deep thinker. I love it. You're an innovator. You're definitely a teacher. I can tell you have a teacher's heart and you want others to learn. Comes through very well, and certainly an entrepreneur. Um, Dr. Krish, I sure thank you for your time here today, and it's been a joy talking to you.
Same here, Monte. Thank you for the opportunity.
And I'm sure we're going to have some follow-up questions we'll send your way once we hear back from people, and I hope to stay in touch in the future as you continue to add value to ultimately farmers and everyone more equitably in the entire production system.
Look forward to that.
All right, thank you, Sivan.
What a great conversation. If you've listened to the AgEmerge podcast for some time, you know we love bringing you guests and stories of how technology is being used to our advantage in agriculture to especially help with the adoption of regenerative practices. We know it's just one tool in the toolbox, but it's a power tool for sure. And if you'd like to learn more about what we're doing to help growers build a solid toolbox filled with powerful soil health practices, check out our website at asn.farm. And there you can click on links to follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. There's a lot of great things happening and always something to learn. Thanks for listening.